No, we're not. We're not winning. We're losing. We're losing miserably. As you said, all Western societies, cancer is increasing. Not only the incidence, but the death is increasing in all major Western countries, and it will continue to increase. The projections are bleak, and it will overtake heart disease at some point. Already in China, cancer has already overtaken heart disease. In our country, the United States, we have about 1,000, almost 1,700 people die each day from cancer, which is about 70 people per hour dying from cancer in the United States. So, and I know there's an increase in other European and countries as far as Far Eastern countries, China, Japan. So the answer to your question is no. We are not winning the war on cancer, and we are losing, and we are not making any major advances. The cancer cell uses a different form of energy than the normal cell. It uses fermentation metabolism without oxygen. This is because the organelle controlling the metabolism of the cell, the mitochondria, is defective. So we have not found any cancer cell that has a normal number, structure, and function of mitochondria, the organelle that controls the metabolic parameters within the cell. So when you have that's the common metabolic phenotype or condition seen in all major cancers. Okay, all major cancers have the same problem, but every cancer may be very, very different with respect to genetic mutations. So even within the same tumor, you have many different tumor cells, and each cell will have a different composition of mutations than any other cell. But every cell in that tumor has defects in energy metabolism, thereby making cancer a metabolic disease. Now, the mutations are not the cause of dysregulated cell growth. They're the effects of the dysregulated cell growth. So here, when that organelle, the mitochondria, becomes dysfunctional, it produces reactive oxygen species. These are carcinogenic and mutagenic. They are radical oxygen species that cause mutations and chromosomal abnormalities in the nucleus and in the DNA. So what that means is that the corruption of mitochondrial metabolism precedes or comes before the mutations that you see in the nucleus, making the mutations not the cause, but the effects. And the great tragedy, and the reason why we're not making any advances in cancer, is because the majority of cancer researchers in government and in academic and pharmaceutical organizations are focusing on downstream effects rather than the real issue, which is energy metabolism. So that's why cancer is a mitochondrial metabolic disorder caused by damage to oxidative phosphorylation in the mitochondria, which then leads to a compensatory fermentation, dysregulated cell growth, and nuclear gene mutations, all of which are downstream. So now we know from many, many studies that normal tissues in our body that do not have dysregulated cell growth have many different kinds of genetic mutations, driver mutations, and yet they have no dysregulated cell growth. We also know of some cancer cells that have no mutations and yet grow out of control.
Aha! Aha!
We also know of some cancer cells that have no mutations and yet grow out of control.
For the first time, as many people survive cancer as die from cancer. But we know that's not good enough. We need to keep pushing, keep striving, keep fighting, so that one day everyone will survive cancer. We will beat cancer sooner.
The majority of cancer researchers in government and in academic and pharmaceutical organizations are focusing on downstream effects rather than the real issue, which is energy metabolism.
Aha! Aha!
So we know this. And then when you put all this together with the nuclear mitochondrial transfer experiments that were done, it becomes no longer credible that cancer can be considered a genetic disease. It's a mitochondrial metabolic disease that cannot grow without fermentable fuels. And we and others have shown that those fermentable fuels are the sugar glucose and the amino acid glutamine.